Here we're looking at section 11.3. So our learning targets for today are to identify types of sampling methods in statistical studies. Then we're going to be recognizing bias in sampling. Then we need to analyze methods of collecting our data, and then we're going to recognize some bias in certain survey questions. Right? So we've been looking at a bunch of data, and now we have to figure out how are the best ways that I can gather that data. That's what this whole section is about. So here's kind of our steps in our statistical studies, right? So first we have to identify the variable of interest and the population, right? What do I care about and who am I dealing with? Then I have to choose my sample that's representative of my population, because as we said in section 11.2, it's often not possible to gather the data from an entire population. Then we collect our data. Then we organize our data and describe it using a statistic, right? And we use a statistic because we looked at a sample. Then I can interpret this data and make inferences and draw conclusions. Okay, so there's a lot of different ways of sampling a population, but we always want to look at a random sample because that random sample is most likely to be representative of a population. So in our random sample, it tells me that each member has an equal chance of being selected. We're not selecting based on certain qualities in our random sample. So there are other types of samples that I'm going to look at in just a second. They're defined by the methods that are used to select members. So each method has some advantages and disadvantages based on what you're looking for and the data you're trying to collect. So some types of samples that we can deal with. For our first one is a self-selected sample. So in a self-selected sample, members volunteer. So this is not the most random type of sample, as we only have people that volunteer for our study. A second type of sample is a systematic sample. So in a systematic sample, we use a rule to select members. So like every other person or every third person, so then we get a different grouping of people. If we're looking at a stratified sample, a population is divided into small groups that share a similar characteristic, and then a sample is just randomly chosen from each of the groups to represent our final grouping. If we're looking at a cluster sample, our population is again divided into those groups called clusters, and then all of the members of one cluster are selected. For a convenience sample, right, only members of a population who are easy to reach are selected. So think about if you're talking about high school seniors. Your convenience sample might just be the seniors that are in your school or in your town. It won't be all high school seniors across the nation because that's going to be a really hard sample to get a hold of. So now here's our first example. So I want to determine whether students in my school like the new design of the school's website. So identify the type of sample described. So A, I list all of the students alphabetically and choose every sixth student. So this I see that I'm kind of using a rule on. So this is a systematic sample. So then if I look at B, I mail questionnaires and use only the questionnaires that are returned. So this tells me that those people that my sample had to select themselves into actually responding. So this is a self-selected sample. So C, I ask all of the students in my algebra class. So I'm asking students who are readily available because they're sitting in class with me. So that's a convenience sample. And then D, I randomly select 2 students from each classroom. So here my students are divided into similar groups by their classrooms, and then 2 are selected at random from each group. So that's my stratified sample. And I would get different data based on all of these samples. So based on what I'm actually looking for, I could pick the best way to gather my data. So now think about these questions and see what you can come up with for them. So now we're going to be looking at bias. This was our second learning target. So a bias is an error that results in a misrepresentation of a population. Okay? So a bias changes my data so it doesn't actually represent the entire population. So I always want to select my unbiased sample. So an unbiased sample is representative of the population you want information about. A sample that overrepresents or underrepresents part of the population is a biased sample. So when a sample is biased, I can't really look at the data, so it's considered invalid data. So I always want to use my random sample because my random sample generally helps reduce the bias in my samples. So let's look at this example. So identify the type of sample and explain why the sample is biased. So part A, a news organization asks viewers to participate in an online poll about bullying. So here's the first part. So the viewers can choose whether or not to participate. So they're just asked to. So that sample is a self-selected sample. So this is biased because the people who go online and respond probably have a strong opinion on this bullying. And often you'll see that with self-selected samples. Most people that self-select into a report or into data groups generally have a really strong opinion on things, or else they probably wouldn't have selected to complete and use some of their own time to do this. So let's look at part B. A computer science teacher wants to know how students at a school most often access the internet. The teacher asks students in one of the computer science classes. So the teacher selects the students who are readily available, right? All the kids in that class. So this is a convenience sample. So the sample is biased because it's limiting. It only limits those kids in that classroom. So it's biased because other students don't have the opportunity to be chosen. It's not random, it's just convenience, and it's all of the kids right here in front of me right now, not taking into account any of the other students in the school. So here's our next example. You are a member of your school's yearbook committee. You want to poll members of the senior class to find out what the theme of the yearbook should be. There are 246 students in the senior class. So now you have to come up with a method for selecting a random sample of 50 seniors. Because you don't want to spend all of your time chasing down all 246 seniors. You want to have a nice number that you can work with. So you have to figure out what's the most easy way to select your random sample. So one thing you could do is you can make a list of all your seniors and assign each senior a different integer, right? Just assign them a different number. So then you can use your graphing calculator or the internet and find some random feature. And there's a lot of places you can do this. So then you can just generate 50 unique random integers. Okay, so here's how you can put this in your graphing calculator. Rand integers 1 through 246, right? And then you just hit enter and it keeps up coming with your different random numbers. So then you would select these students. So you would pick those students that corresponded in that step. This is the best way to find that random sample, is to use a random number generator to help you with that. So first, when you're using those random number generators, you have to assign digits, assign numbers to your data or your people, and then use your random number generator to actually select the numbers for you. So here's your monitoring progress. So I want you to try and come up with some answers to these. So here's our methods of collecting data. This was our third learning target. So there's 4 different methods we're going to look at. So an experiment is where we actually do treatment on individuals to collect data as their response. This can be a medical treatment, or any other action that we do is considered an experiment. If you do something as part of collecting your data, that's an experiment. We also have an observational study. An observational study is where I just observe the individuals and measure my variables without actually being part of the environment that they're in. This is often used when it's difficult to isolate the variable being studied, or if we're doing treatments that it's not ethical to do, to withhold like food or water or certain medications. That's not an ethical thing, so we can just use observational studies. Oftentimes we see surveys. So surveys is where we deal with one or more characteristics of our population, and the survey is just kind of where you're asked questions. You've probably all filled out many surveys, as they're pretty easy to deal with and get data from, and they're just very common. So then we're talking about our 4th one is a simulation. So a simulation uses a model to reproduce the conditions of that situation, so it as closely matches the real world outcomes as we can. So simulations allow us to study things that are dangerous to create in real life, or that are just impractical to do. So we can use those simulations to help us come up with some data that we can use. So now let's look at our example. So identify the method of data collection each situation describes. So a researcher records whether people at a gas station use hand sanitizer. So I'm just gathering data without controlling the individuals or without actually becoming a part of the study. So this is an observational study. Let's look at B. A landscaper fertilizes 20 lawns with regular fertilizer mix and 20 lawns with a new organic fertilizer. that landscaper compares the lawns after 10 weeks and determines which one's better. So here I see that something is actually being done by somebody. So that's going to be an experiment. When I gather data after doing something different, that's called my experiment. So here I want you to try this monitoring progress, see what you can come up with for that. So now we're looking at bias in survey questions. That's our last learning target. And when you're creating a survey, you want to create a survey without any bias because you want to have some valid data to support your arguments or to share out. So there are certain survey questions that are considered biased questions. And those biased questions lead to inaccurate results. So a biased question could encourage a particular response. They don't actually provide enough information to give an opinion, or they're too sensitive to answer truthfully, like the person might be scared to answer incorrectly. Biased questions also address more than one issue. You want your questions to be very to the point and simple to follow. So let's look at our example. A dentist surveys his patients by asking, do you brush your teeth at least twice per day and floss every day? Explain why the question may be biased or otherwise introduce bias into the survey. Then describe a way to correct the flaw. So first thing we can see that if you brush less than twice per day or do not floss, you might be afraid to admit it because the dentist is the one asking the question. And these are just, you're supposed to brush twice a day and floss. So you might just tell your dentist what you think they want to hear. So that's where some bias comes into play because you might not answer this question truthfully. So one improvement could be to have patients answer questions about their hygiene on paper and then put the paper anonymously into the box. It's a lot easier to get actual realistic data if things are anonymously done, right? Because now I'm less afraid to answer because I can write my answer on paper and no one knows it's me. That's a way that I could just easily correct this flaw. I could still ask the same question. I don't have to ask my question. Just the method that I collect the data can be changed to decrease the bias in that question. So now I want you to look at this one and explain if you think this is bias or how it could be bias, and then how I can correct that to make it an unbiased question. So let's look at our learning targets. The first one we did was identify types of sampling methods in statistical studies. So we looked at a bunch of different types here, and these are not the most random samples, so we always want to go back to our random sample being the best. Then we looked at different ways that there's bias in sampling. Then we looked at the different ways that we could collect data and where they would each come into play and be useful. And then we looked at bias in survey questions. And we looked specifically at survey questions because this is generally the easiest and most commonly used way to gather data. So now that we've looked through all of these learning targets, go ahead and work on the homework for 11.3.